This is Jack Jackson. Today we're going to continue our look at which conditions lead to triangle congruence by looking at the side-side angle or angle-side-side condition. And this one is pretty interesting because some interesting things happen here that didn't happen in the others. We saw that side angle side, side side side, angle side angle, and angle angle side, if they produce a triangle, then that triangle must be of only one particular size. But something interesting happens on the side-side angle situation. So we're going to actually construct this with angle side-side. So we're going to start by constructing an angle here and make that first, okay, with our compass. Next we're going to with our protractor. Next we're going to choose a length B along this side, and next we're going to choose the length A. Now the length A has to be opposite the angle A, and we choose this with our compass. We set it to this length of A, and we know that from this point up here that we must in fact have this length. But the problem is, if you look here, in this case this length might be too short, and no matter where we put it, the vertex has got to be on this circle, but it's also got to be on this red ray down here at the bottom, and of course this circle and this ray never intersect each other. And so we see that if this side A is too short relative to the angle on the other side, then it's not going to reach. Okay, however, if this side is a bit longer, it could so happen that that circle just touches perfectly in exactly one spot. We have a word for that. We say that the line, this ray down here, is tangent to the circle, or the circle and the ray are tangent to each other, meaning they intersect each other in exactly one point there. When that happens, this is actually a right angle right here where they meet, and there's exactly one triangle possible. So if it's too short, it doesn't reach. If it's sort of just right, it reaches once. But look what happens when it's a little bit longer. Now that circle and this ray actually meet in two places, so they're actually two different triangles. One is the triangle going from here to here to here. Let me relabel this a little bit. So this one is supposed to be point A, and this one up here is going to be point C. Okay, so those are different possibilities here. Let's see. Let's make this. Okay, so point A and point C we can have, but then the last thing we get is point B, and this could be B might be here, or B might be here. We have two possibilities. Not just anything, but two different triangles. So one triangle, and you see that these triangles are completely different. From A to C to B2, and then from A to C to B1 are completely different sized triangles. The area of this one over here using B2 is much smaller than the area of the one using B1. And the angle at B2, the interior angle here at B2, this angle which is right here, is much bigger than the angle right there on that one. So these angles are completely different sizes. Just give them some different colors there. And so we see that those two angles are different. And of course then the two lengths for side C, opposite angle C, there's two different. One's a short one from A to B2, and the other one's a bit longer from A to B1. So they're actually two different sets of measurements. Let's see. Let's see if I can kind of line these up a tad better here. And I'm going to do a little, bear with me here just a minute, I'm going to rename a couple of things. This is going to be angle A, and this is side A and B. And so there's A in both cases. This is angle C. We'll call it angle C, C2. So we'll label this C2. Okay, and that's this angle, that's angle up here at the top, this little angle right there, C2. So A and B are the same in both places, but C is different. So this C1 is from B1 to A. So let me relabel that C1. So that's the bigger C. Oops, that should be little lowercase c. Because it's a size. So C1, and this is C2 is this one. So notice that those sides do not correspond. They correspond, but they're not the same length. Okay, and then the angles. Angle A is the same either place. Okay, angle C is different though. Here's angle B2. And B2, let me go ahead and make that. We chose brown for that angle. And here's B1. We'll chose gray for that. Maybe I'll choose something different. Let's see. We'll choose purple. And label that B2. Okay, and notice there those are different, and then C2 and C1 are different too. Do I even have that one measured? Okay, so C1 goes from B to C to A. I can measure that angle. We'll call that C1. Okay, and notice that that's different. So these measurements here let's make them all the same font and make them a little bit bigger where we can see them. So in both cases, A and B are the same. They were given the same, and angle A is the same. But the rest of the measurements then turned out to be different. So A is the same, B is the same, C's are different, angle A is the same, angles B are different, and the angles C are different. Okay. So we have two complete triangles with two completely different sets of measurements, and yet both of them have a side, an angle, and a side that matches and is congruent with the other one. I mean, sides, angle, side, side, or side, side, angle that matches, and yet they're two different triangles. So this is what we call the ambiguous case. You don't get just any triangle, but you do get two different triangles, two completely different sets of measurements here. Now, let's go a little bit further. If I go a little bit further still and make A the same length as B or even longer, now we see that this circle and this ray, see it doesn't intersect over here, that intersects in exactly one place, and so we're back to one solution again. That one is sometimes called the written as capital S, little s, A, and this is SSA plus this side is larger than this side. So it's a little extra information. And that big S, little sa is enough to make the triangles congruent because you only get one size, because in this condition there's enough. But notice that's not just SSA, it's a little bit extra information. So if we knew some extra information like that, for instance, or sometimes some other pieces of information, then we might be able to narrow it down. So back in the ambiguous case, if we narrowed it down to this point, and we said, for example, the angle at B was an obtuse angle, then we would know it was this triangle, and it would only be that one. But if we don't know that, it could be either one of these two. One final thing, when you do have the ambiguous case, I want you to notice something. This triangle right here, from B1 to C to B2, is actually an isosceles triangle. So that means that this angle right here is congruent to the little angle that's right over here. But this angle right in here and this one here are supplementary. So that means that this angle and this angle, the two possibilities for angle B1, for angle B, B1 and B2, must be supplementary. So if you add these two together here, you must get 180 degrees. There's the other angle I was missing a while ago. Okay, and so this write-up here does go on to talk about this some more. You can read this, and we can work through this. Okay, so we're gonna, like we did before, we're gonna kind of stop the video here in just a second, and then we're gonna come back to the SSA condition where we can operate it not by adjusting the sliders here, but rather by typing in some numbers and have you actually compute or to draw some of these things and work out the details yourselves as we go along. So that'll be in the next video, and this one concludes now.